Okay, so first, thanks a lot to have invited me. I'm very happy to be there and to be. It's like when you see your baby 21 years later. He has done a lot of things by itself, and that's very nice and fulfilling. So I'm very happy to be there. I'm going to give you a keynote, so it's about Scapy, personal things about Scapy, and I hope you will enjoy it. So first of all, it's a brief history about Scapy. A few things that I think are not that known. Some of them I have already spoken about, but it was a long time ago, and I don't see a lot of old people here, so maybe they will be new for you. So I think what made Scapy successful is that it's a tool that came from a need, and all the things I have put inside it were coming from because it was my a tool I used every day for a long time. Each time I had a need, I put it into it. And if you look at the commit, each time you see a new feature, you say, oh, at this specific date, he needed it for something. At the beginning, let's assume we are in 2002, 2003. We had a lot of network techniques. You will see some of them very old, like ping of death, etc. Some are still up to date. We had a lot of stuff. Source routing is not something we encounter a lot nowadays. And these ones are supposed to be dead bugs, but actually you still find them sometimes. And specifically in embedded systems, because they have a tendency to redevelop everything and make the same mistakes, etc. We also have a lot of tools. For each technique, you usually have 2-3 tools to implement it in a different way. And at the time, well, you wanted to do something, you found the right tool, use it. But I wanted to combine stuff. I wanted to do, for instance, when you discover remote networks, it is sometimes interesting to scan networks. So scan a lot of IPs on a different set of ports, but with fixed TTL, so that you can have a view, like I call this slide scanning, because you have a view at this distance, then this distance, then this distance, which give you a sense of 3D, I would say, a sense of depth on the network you wanted to discover. And you could not do it at the time, like asking Nmap to set the TTL at some point, or even automate it for all the TTLs you were interested into, or setting arbitrary things in the packet you send to do the scan, like the more fragments flag, which is also an interesting thing to play with. Same if you knew how to do hard cache poisoning, you knew how to do a double .1q encapsulation, you could not combine the attacks. I spoke about ether leaking, ICMP leaking on the previous slide. I pointed to it. So playing with padding data is also something tools do not give you the ability to do. Also, what was interesting, specifically when you do UDP scans or some traceroutes towards UDP services, is that, as you know, a positive answer is actually no answer at all when you do a UDP scan, which is not very reliable actually. It's much more reliable to reach the application layer so that you have an answer. And then the answer means there is actually a service listening. So being able to send you to get this answer combined with a UDP scan or a traceroute is also something you could not do, like a DNS request or an ISA KMP request. So what did you do? You had to build your own tool. At the time, the best library out there was libnet, and this is all to make an ICMP packet with libnet. So it's C, so it's much more verbose than Python for sure, but you had a lot of stuff to prepare, to initialize, etc. And yeah, this is the first slide. There is the other part. This is you recognize the IP layer, and then you send it. So it's I mean, we could do better than this. And that's how I came up with the first prototype named PyRat, where I, because I was playing a lot with VLAN hopping attacks and with ARP attacks, I said, but actually it's only layers that you stack one onto the other. If you know how to do 1.1q layer, it's the same as doing 2 or 3 or how many you want. And it's only a matter of combining different layers and stacking them up one onto the other. That's why I came up with this first syntax. And also I said a lot of values, they're always the same. We don't, we should not have to provide them as long as we don't need to change them from working default values. This is a very dumb idea actually. I mean, a nice, a simple idea, but it was something the C could not provide, but it was easy to do in Python. And also a way to send packets on the wire without initializing a lot of stuff. So here Python played a big role also to make the equivalent of the previous program into one line. Then came Scapy with also a new idea, which was, what if you put a set of values inside a field and it could create what I call an implicit packet, and then by doing this you could define in one line 60 packets. 60 packets that represent a set of stimuli that would give you an idea of something. And by doing this, everything became scanning. So scanning, sweeping through a lot of values. So even a traceroute could be seen as a scan. It's a scan where the TTL is changing. And that's the other idea that came with Scapy. There were other ones that was probe once, interpret many. So I wanted that you send a lot of packets, you get answers. It's something that is noisy, that can bother your target. But once you have the results, you could work on the result and view them as many times as you want with the angle you want, so that you don't have to probe again and again and again. Because once you want to see the TCP port, once you want to see the TTL of the answers, you forgot to think about it. So you get as much data as you can, and then you dig into the data without probing anymore. And then came also this idea of decode but do not interpret. That was one of the problems I had when you deal with, I would say, not so standard way of configuring your firewalls or your embedded systems, is that when, for instance, you send a TCP SYN packet and you have a TCP reset, it may say that the port is closed, but it could also be a firewall on the path that forge the reset packet, and the difference would be seen on the TTL of the answer, for instance. And programs like Nmap interpret the result, say the port is closed. Maybe the port is open, but you did not reach it. So that was what was all about the concept of decode but do not interpret. It's up to the human to interpret things. So it's better for the program to say, I got a reset, than saying the port is closed. And that was actually what Scapy was meant to mean. It was a scanner in Python. Some key events. First commit. It was one Python file of 2,000 lines of code. And because it was one file, it was easy to manage it with RCS. I don't know if many of you know this very old version control system. It works file by file. It's not remote, it's only for you. It was very practical for the beginning of Scapy, and I work with RCS a lot with Scapy. And the file grew a lot up to 14,000 lines. One big 14,000 line code. So it was, I mean, it took me like 5 years to grow up the courage to split this big file into something more reasonable. It brought this, I would say, this breakout in folders, and it means that I had to abandon RCS, and I went to CVS. No, we created a team of maintainers in 2012, 2013, because there was I would say a slowdown in the development. Many contributions were not taken into account as they should have been. So I asked a few friends, and now it's up to 4 maintainers, and we had 400 contributors. So it's the profit step. So that's perfect. And we still have one creator. It will not change. And this is the guy that comes to keynotes and do nothing. So we moved to from Bitbucket to GitHub, because at some point we were on hosted on Bitbucket. This was a move initiated by the maintainers, not myself, which was actually a great step to take, because it's also enabled to get more contributions and to benefit from the ecosystem of GitHub, and know a lot of stuff are automated. We also made this nice logo you have here. I mean the one you have around your neck, and this version. We also had a very big documentation, and about the logo we also achieved, we unlocked an achievement with spot the logo here on a TV show. It's a French story, I don't know, in German it's this one, I don't know if you know it. So that's a big achievement. I mean, it's an obligatory right of initiation for a program to appear into a film, I think. These are the biggest commit providers, so I'm not even first. And you know that I was very good at the beginning, but I'm almost retired here. This is Gabriel, a very good commit provider. You have the maintainers. So here, thank you, Niels. And Dirk Loss. So he was a nice side wing at this period. That was nice to have him too. No, a bit of fun things, because we are here to have fun. It's written in the things we have to do today. On more than 20 years, I went through all those version control systems. So my preferred is still Mercurial, but I have to admit that the truth is that nobody uses Mercurial anymore. I'm quite happy with Git. So I started with RCS, CVS, SVN. Never use SVN. It's a bad copy of bad concepts. And I think SVN, they made like 10 years before they were able to version SVN code into SVN. And if you compare, when we have the good concepts, Mercurial and Git are actually much more advanced systems, and it took like a few months to have them working. We still have the first RCS commits into the Git, so I checked, it's the one you showed, Niels, it's a good one. I checked the first numbers. It is used in many places Scapy for unit tests, like even for OS networking stack, it's used for Linux, OpenBSD, RT, FreeBSD, and Riot OS. In the eBPF ecosystem too. It's used for sure in several exploits. So one interesting thing is it was also part of the, if you heard about it, NSA Vault 7 leak, because it was part of an exploit named Extra Bacon, which is an SNMP RCE on Cisco ASA. So it's part of an NSA leak. Well, we have a few exploits with IP or vulnerability proof of concept on IPv6, .11, Bluetooth Low Energy for sure. And more interesting, it's part of an ICS exploitation framework named ISF. So it's not for all the exploits, but part of them use Scapy. PPPoN, it's a PlayStation 4 RCE on PPPoE. So it was on the other part. And also part of Ponagotchi, which is a kind of Tamagotchi, but you do not, to feed it, you have to have it hack Wi-Fi networks, and it's very nice and all. So I just discovered the project quite recently, and well, it was fun. A long time ago, we also had advertisement squatting. So if you look for Scapy, the advertised first link was about Skype actually. So you can download Scapy to call anywhere in the world. I did not know this, but okay. Also, we have a quite large user base, so it means we have a lot of tickets, and among them, a few of them are a bit, stands out. Like I think we were not able to manage this one, I think. This one is serious, but here you recognize a YubiKey one-time key here in the title. So, okay. And I don't know if we were able to fix this one. No, I don't. These are about my preferred tricks and the things I like about Scapy. The first one is Scapy pipes. This is I think one of the most powerful features in Scapy, but it is not very well done. How many of you know about Scapy pipes? Great, nobody. So it means that I was inspired to make a small part about it. So it's all about automatizing stuff while keeping interaction. So automatic interaction, at the beginning you had SR, SRP, so for sure everybody knows it. So you send something, you get something, but it is sufficient if you want to answer to a stimulus. Then came what I called answering machines. Now I realized it would have been much better to call them transponders. It was a cooler name. Here, for instance, one written by Guillaume is here you provide a filter about what are the kind of packets that are interesting your transponder. Here it's a .11 probe request, and then you make a method explaining how to reply to this. So it's exactly the inverse than SR. You get something and you answer something. And here in this case it's one answering machine made to create fake access points that you can see here. Okay. But it's still insufficient. Then I came with the concept of automata. So I did not invent the concept of automata for sure, but trying to have a nice way to describe an automaton. See, it's done creating a class and using a lot decorators. So you decorate your methods to make them states here and here, condition or a transition, and it's a condition to make a state transition. And actions you can link to a transition. So this is a very simple one. But it enables you to do much more complicated protocols, even if they are simple in real life. A transponder cannot do a TFTP request, for instance. So this is a more complex automaton that is able to make a TFTP read request. Because you have to ask for a file, then get a lot of chunks, assemble them, write them, ask for, manage some timeouts, etc., etc. So this is done through Automata, but I was still not satisfied with it because Automata are actually, once you did it, it was quite rigid. You could not work with them in real time. So then came the last step, which is Scapy pipes. So the need I came up with was, so you bet it, I work for Airbus, it was an avionic equipment. So let's call it an embedded device. But you have two devices, you remove one and you want to interact with the second one. But the second one, to work, need to think is still linked to the first one. So you have to emulate a lot of things the first one is doing. And for the two to work, you have a big initialization dialogue. You have heartbeats to answer to, but also heartbeats to send. You have requests coming regularly about different things. Oh, can you give me this info or this info? So you have to answer this. If not, the device will not work correctly. Everything is on the same link, physical link. So when it's Ethernet, it's easy to understand that you can have different programs working on the link, but on specific buses, you cannot. You have only one resource being able to access to the bus. So if you want to cut your problem in different pieces, all the pieces will have to find a way to share the access to this link. And you still need to interact with it to do the test, like a human, and react using what you have seen with the inspiration of the moment on what you want to do, what you want to send. What do you want to stop the heartbeats? Do you want to change at some point which kind of answer you will give to a given request, even though it is automated? And the concept of it was creating a graph with nodes and links between the nodes, and that would move messages across the nodes. And it's not a new concept. I mean, graphs like this exist in different fields, like for JIT-streamer, even in networking, they do exist. But here it enabled, the concept of sink, source, and drain is something that was not new. So each node can be this, and we have an event loop running in the background. So it's a bit like Async.io, except Async.io did not exist at the time, and I would like to move to Async.io at some point. And what it looks like is that you create nodes like a sniff source. You will sniff on the loopback. Here I have a transform drain. It means that it will take everything and apply this to the message. And this will open another terminal, so you can have a side window where information can come up. And here I say that my sniff source is connected to my transform drain, that is connected to my terminal thing. And that's pipe engine, I start it, and then it will flow like this. And while it is running, I decide to add a periodic source. So it will send a tick every 2 seconds. I add it, and I connect it to my term sync. Then I add a CLI feeder, so it's something with my CLI I will be able to inject things in my graph at the same time. So everything here works in parallel, and that's how I managed to have I would say a satisfying solution to the need I had to interact with complex equipment. And for instance, here is a simple way to take all the traffic on one interface and to copy it onto another interface. That was also a straightforward example. Okay, how much time do I have? It's
around 10 minutes.
Okay, well, perfect.
15 minutes.
And so this was a big one thing I would like to tell you. If you have some time, have a look at this feature. It can be quite interesting in some complex situations. It's a big, I think it's a nice way to cut big problems into smaller ones. Now, the other nice things we had, so a long time ago I made this to create executable zips. So it was everything of Scapy inside a zip that was executable. So I have a thing for one file stuff, you understood. And this is quite easy to do. You make the zip. Actually, you know, the zip header is at the end. It's make it possible to add files, which means we can add stuff at the beginning and it will still be a valid zip file. But if you add things like this, like I did, you mess up with offsets. Fortunately, a zip is able to fix them. This is what happened here, and I made an executable zip, a working and clean executable zip that you could download very easily and run. It's not working anymore, but thanks to Gabriel, we use now a zip app, which is the modern way of doing it and the clean way. And we have a scapy.zip, and we have this domain name here. And if you do this, curl minus GLO, so to remember it's like Jennifer Lopez. Okay, you will have a zip scapy version.zip. If you make it executable and run it, you have Scapy running, one file, no installation. Could be nice to, I mean, if you're lost in the Amazonian jungle, you only have one internet connection and a laptop, but no Scapy, you can install it very easily. This was also nice. It's actually something I used a lot, even if it seems a very niche. It's something that will parse, and it's an inverse of xdump. It will parse hexadecimal dump and make it a string, then dissect it as an IP, for instance. So it works with, for sure, with every layer, Ethernet dot from xdump. And it's nice when you capture something unexpected on TCP dump running and say, oh, this packet, oh, I did not capture it, I only have it in xdump. You copy paste it in Scapy, you can manipulate it, examine it, etc. This one also came only at some point. It's when you have two packets, one is working, one is not, you don't know why. It's better looking on Scapy because I did not find how to put the colors correctly and easily. But you see that between those two packets, TTL1, TTL2 and foo and bar, you have a difference here. And so here two lines also with difference. TTL is changing here, checksum is changing here. It can be ugly sometimes. And this one I did not commit it yet because by doing the when I did the presentation, so I had slides to make. So instead of making slides, I worked on Scapy, which was and then I had this long thing I had in mind. It's something very old code I did elsewhere that I wanted to integrate into Scapy. So I took some time to dust it. It's not committed yet, but I hope I do it before the weekend. And it's something that happened a lot on my side on embedded systems, but I suppose it's your case. Embedded systems do use CRCs a lot. This is a case where you have a protocol you don't know a lot. It's not very well specified. You know there is a CRC. You may know where it is, but you don't know exactly which CRC because even with the polynomial given, you have a lot of variants. Is it the polynomial? Is it the reverse polynomial? Big Indian, little Indian? What is the initial value? Do we reflect the input? A lot of small parameters. And this one, you give just this, and it will brute force try all the well-known polynomials in different forms with all the different parameters here that we usually think that is -1 or 0, yes or no. And it will give you that it has found this CRC32 So he knows that this one is actually defined. So when it is defined, it will also find which one the actual name. So you know, I chose this one. I hope you see why. So here it will find that this is the CRC. You see it here. That is done on this part of the message. Okay, and for sure it enables you to compute CRCs, all the ones that are known, and to define new ones. Just give the polynomial, the different parameters, and you have a working CRC function here. And this was my final slide because it's about the future. I have no conclusion because the Scapy adventure is not finished. And I will be very happy to answer your question, either no, until we have no more time, or later in the day. Thank you very much.